Right, next study conversion of inclusive method into exclusive method. Okay. Now yesterday we have seen only exclusive method. Now if the problem is based on inclusive method, how to convert it into exclusive? Now to convert inclusive method into exclusive, we have to use this formula which is known as CF. CF is nothing but correction factor. CF is nothing but correction factor. By using this correction factor, you can easily convert inclusive method into exclusive method. Now, the formula of correction factor is lower limit of second class interval minus upper limit of first class interval. This is divided by by using this formula you will get one value which is known as correction factor, and by using this correction factor we can easily convert inclusive into exclusive. So this formula is most important. This is not related only for mean, it is related to mean, median, mode, whatever may be the statistical method. If the problem belongs to inclusive method, by using this correction factor formula you have to convert it into exclusive. Then you can use the same formula. Okay, I'll give an example first. Take one example. From the following data, calculate arithmetic mean. Okay. Make two columns, class interval and frequencies. Now class interval is 55 to 59, frequency 12, 60 to 64, 24, 65 to 69, 36, 70 to 74, 20, and 75 to 79, 8. So well, this much information is given to you, and by using this information you have to calculate what? Arithmetic mean, right? Your arithmetic mean formula remains same, but first of all check out whether this problem belongs to exclusive or inclusive, right? Now this is exclusive or inclusive. Now it is inclusive method because upper limit is not repeated once again as lower limit. If upper limit is repeated once again as lower limit, it is exclusive. Now here it is not repeated. See here, 59 is not repeated, 64 is not repeated, 69 is not repeated. So it is called as inclusive method. So whenever there is an inclusive method, first of of all we have to convert this inclusive into exclusive. So below this, write down the formula of correction factor. Correction factor is equal to lower limit of second class interval minus upper limit of first class interval, and this is divided by lower limit of second class interval minus upper limit of first class interval divided by 2. Now see, first it is given as lower limit of which class? Second class. Here second class is 60 to 64, right? What is the lower limit? 60. So 60 minus upper limit of first class. Your first class is 55 to 59. So upper limit is how much? 59. And this is divided by 2. So answer is 1 upon 2, which is nothing but 0.5. Therefore, correction factor value is 0.5. Your correction factor value is 0.5. Clear? Okay. Now, by using this correction factor, I can easily convert these inclusive classes into exclusive. For that purpose, prepare one column which is known as class boundaries. CB is nothing but class boundaries. When you convert inclusive to exclusive, this column is treated as class boundaries. Now, rule is important here. How to use this correction factor? To convert inclusive to exclusive, listen carefully. This correction factor, always you have to deduct from lower limit. Always you have to deduct from lower limit, and same correction factor you have to add in upper limit. In all the classes. Now see, lower limit is 55. 55 minus 0.5. It comes to 54.5. And same correction factor add in this upper limit. So it comes to 59.5. Correct? Same procedure for other classes also. 60 is the lower limit, so 60 minus 0.5. It comes to 59.5. And same 0.5 you add in this 64. 64. Now see, your upper limit is repeated or not? Correct? So when upper limit is repeated, it is treated as exclusive. Now 65 minus 0.5 is 64.5 to 69.5. 69.5 to 74.5. And last is 74.5 to 79.5. I'll explain once again. The rule says that this correction factor always you have to deduct from lower limits, and same correction factor you have to add in upper limit. You will get class boundaries, and those class boundaries are in the form of exclusive method. Okay. Now, once you know this correct class boundaries, now go for mean. Formula of mean is x bar is equal to summation fx divided by f. Nothing is given, you have to use direct or shortcut method. So go for shortcut method. You have calculators, you can make use of this. Okay. Now here, n is nothing but total of frequencies. N is nothing but total of frequencies. Your total of frequency is 100. I'll tell you the value. 100. Now to calculate mean, now you know n value, you know the frequencies which are already given, right? Only thing is we want x value. So prepare x first. Here x is nothing but mid value between the class boundary. Mid value between the class boundary. How to calculate mid value? Lower limit plus upper limit divided by lower limit plus upper limit divided by 2. I think it is 57. Correct? 57 is the x value. What will be the next x value? There is a perfect difference of 5. Right? In class interval there is a perfect difference of 5. So add 5 here. 62, 67, 72 and 77. And the last column is fx is nothing but frequency multiplied by x value. Frequency multiplied by x value. I'll tell you the values. 12 into 57, 684. 24 into 62, 1488. 36 into 67, 2412. 20 into 72, 1440. And 8 into 77, 660. This is your summation. Just you have to multiply this frequency and x values. You will get this problem and make the total of this. Now the total is 6640. Total is 6640. Okay. Apply the formula. 6640 is the fx value divided by n value is how much? 100. Therefore our mean value is 66.40. Mean value is 66.40. Steps are important. Steps you have to remember. First step, you have to check whether the problem belongs to exclusive or inclusive. If it is exclusive, directly you can use mean formula. But if it is inclusive, use the correction factor, calculate correction factor, go for class boundaries, then go for mean formula. This is clear? How to calculate correction factor and how to use this correction factor to calculate class boundaries. This is important. Remaining steps are same. Okay. We'll solve one more problem, then we'll go for median and inverse. Okay. Right. Calculate arithmetic mean. Calculate arithmetic mean. Make two columns, class intervals and frequencies. Class interval and frequencies. Class interval 10 to 19, frequency 8. 20 to 29, 12. 30 to 39, 36. 40 to 49, 28. 50 to 59, 44. 60 to 69, 32. 70 to 79, 20. 80 to 89, 6. And 90 to 99, 4. This much information is given to you. Now see, which method of class intervals are given? Inclusive or exclusive? Inclusive, because upper limit is not repeated once again as lower limit. So write down correction factor formula, find out correction factor. I'll write over. Correction factor is equal to lower limit of second class interval minus upper limit of first class interval. This is divided by, every time you have to calculate. I also know majority of the time, listen, majority of the time your correction factor value will be 0.5 only. Majority of the time, but in some problem it will change. So don't take risk. Calculate correction factor, then go further. Now see, lower limit of second class. What is the second class here? 20 to 29. What is the lower limit? 20. So 20 minus upper limit of first class. What is the upper limit of first class? 19 divided by 2. So again it is 1 upon 2, which is nothing but 0.5. Therefore correction factor value is again 0.5. Correction factor value is 0.5. Up to this is clear? Now once you know this correction factor, we have to start with class boundaries. Now how to prepare this class boundary column? Now you know the rule. This correction factor always we have to deduct from lower limit, and same correction factor we have to add in upper limit. That's it. So 10 minus 0.5, it comes to 9.5 to 19 plus 0.5 is 19.5. Correct? Like this, calculate others also. 20 minus 0.5 is 19.5 to 29.5. 29.5 to 39.5. 39.5 to 49.5. 49.5 to 59.5. 59.5 to 69.5. 69.5 to 79.5. 79.5 to 89.5. And last is 89.5 to 99.5. Check your class boundaries. Now it is exclusive or inclusive? Exclusive, because upper limit is repeated once. Now you can go for mean formula. What is the formula of mean? It is summation fx divided by capital N. Capital N is nothing but your total of frequency. Capital N is nothing but your total of frequency. I'll tell you the value. Total is 190. Total of frequency is 190. Okay. Now which column we have to prepare? X. To calculate mean, we have to calculate x value. Now x values are nothing but mid value between the class bound. Don't consider these original classes, because we have converted class intervals into class boundaries, right? So 9.5 plus 19.5 divided by 9.5 plus 19 means 29 divided by 2 is 14.5. First x value is 14.5. Now every time don't calculate these x values. Check the difference in class boundary. There is a perfect difference of 10 in each class, right? So here also you add 10. Next one will be 24.5, 34.5, 44.5, 54.5, 64.5, 74.5, 84.5 and 94. These are your x values. Now once you know x values, last column will be fx. Last column will be fx. That is frequency values multiplied by x values. Frequency values multiplied by x values. I'll tell you the values. Here first fx is 8 into 14.5 is 116. 294. 1242, 1246, 2398, 2064, 1490, 507, and last is 378. 378. This is your summation. Your summation fx value is 9735. 9735. Now apply the formula. You know fx value 9735 divided by n value is 190. Therefore x bar value is 51.2. 51.23. can verify the answer. Okay. But procedure is clear or no? When it is inclusive, how to convert into exclusive. Once you convert exclusive method, again remaining steps are same. Calculate x, then fx, go for the mean. All of you have followed this? This is not only in case of mean. You have to solve the problems on median also, mode also. They make you inclusive method. You have to convert it into exclusive. Then you have to apply the formula. Okay. Up to this is clear.